Algebra 2, target 6. I can factor a quadratic expression. Day 2, simply more practice. All right. In review, to factor means to find what is multiplied. So really we're dividing a expression into two different pieces. The steps for factoring a quadratic, you want to identify your coefficients, a, b, and c. You're going to multiply a and c together and see what multiplication of a and c is the same as the addition to get b. All right? The two numbers we get there will be m and n. Then we're going to fill in our box. We're doing the reverse of the box. Fill in our box with ax squared, mx, nx, and c, and then we can factor the rows and columns, do our ups and our downs. So let's do some more problems. Okay, factor these, pause, and go as you need. For the first one, we got 9y squared plus 12y plus 4. We're going to look and we're going to see our a times c, 9 times 4 is 36. We want to multiply to get 36 and add to get 12. So start trying. Make a list of numbers until you find one that adds to 12. 1 and 36 adds to 37. No, that doesn't work. 2 and 18 adds to 20. Keep trying. 3 times 12 equals 36, but 3 plus 12 equals 15. So try 4. 4 times 9 equals 36. 4 plus 9 equals 13. So we'll try 5. 5 does not multiply to get 36, so we'll try 6. 6 times 6 multiplies to 36 and adds to 12, so 6 and 6 are our terms. So as we build our box, our first term is 9y squared, so that'll go in our first box. Our last term is 4, that'll go in our last box. And then our two terms here are 6y and 6y for the 12y. Now we're going to go left, right, up, down. So as we go left, right here, or right to left, 6y and 4, the largest number they have in common is 2. Going right to left there, going across, 9y squared and 3y, they have, 9y squared and 6y. They have 3 in common, and y squared and y have y in common. Going up, now because these two numbers are the same, ups and downs are going to be the same as lefts and rights. So this one's actually kind of easy. Once you get the left and rights, your ups and downs should be the same. So this should be 3y, and that should be 2. Because 6y and 4 is the same whether you do it here and here, or here and here. Same thing with 9y squared and 6y. So our factored form here, our width of the box is 3y plus 2. Our height of the box is 3y plus 2. Since they're the same, we can kind of simplify that and say 3y plus 2 squared. All right, this is one of our special factorings. Since it worked out to 6 and 6 right here, we could just say, okay, this is a perfect square and only do 1/2 of the box. Let's try the next problem. All right, so our A and our C are 4 and 49. Take 4 times 49. We get 196. All right, what multiplies to 196 and adds to negative 28? This one's going to take a while, so we're going to need to maybe skip around a little bit. Knowing that it's negative 28, I know it's going to be quite far from 1 and 96. Negative 28, I just happen to know is negative 14 plus negative 14. All right, what's 14 times 14? 196. All right, This is also a perfect square. Anytime you get those big numbers like that, you can go through your entire list, or you can say, okay, maybe there's a trick. And this trick right here is it's a perfect square. Let's put our terms then into the box. All right, so we got 4r squared is our first term, 49 is our last term, and then our middle term is negative 28r, which we split into negative 14r and negative 14r. Now we know because of these, when we go across, it's going to be the same as going up. So as we go across this way, negative 14r and 49 is going to be a negative. The largest number 14 and 9 have in common is 7. So it's going to be negative 7 here and negative 7 there because these two values are the same. As we go across this way, they have an r in common. And then 4 and negative 14, they have 2 in common. So it's going to be 2r minus 7. And because both the width and the height are the same, it's going to be 2r minus 7 squared. That is our factored form. All right, so let's look at the last one. This one only has 2 terms. Something's missing. Well, I am missing my b value. So that means b is 0. So I want to say, how can I multiply to get, again, negative 16? But now I'm going to add and get 0. This is a special factoring as well. This is called the difference of squares. Because this is something squared and this is something squared. We'll do it the same way. Maybe eventually you'll notice a pattern. We can make our list, negative, okay, 1 and negative 16. That adds to negative 15, too big. 2 and negative 8, that adds to negative 6. 4 and negative 4, that adds to 0. So our numbers are 4 and negative 4. Now notice, they're the same number, just opposite. That should make sense. How do you add to get 0? You add to get 0 with the same numbers that are opposite. So what we'll do, we'll fill in our box. Our first term is 16x squared. Our last term is negative 1. Our middle term is 0, which we write as 4x minus 4x, so that we can fill in our box. And then we'll do our left and rights. What do 4x and negative 1 have in common? 1. What do 16x squared and 4x have in common? And that's 4x. We will look up. What do negative 4x and negative 1 have in common? Negative 1. And what do 16x squared and 4x have in common? They have 4x in common. So that means our factored form, the height is 4x plus 1, and the width is 4x minus 1. So that factors to 4x plus 1 and 4x minus 1. And again, it's a special form. There's shortcuts for that. For now, we're just going to continue using the box to do it the long way. All right, now, sometimes you come across tricky problems that have a common factor before you put them in the box. What you need to do is you need to say, okay, there's something in common that I can pull out. So as I take a look at this first problem, 8, 38, and negative 10, they're all even. So what you want to do there is pull out your 2. Pull out 2 first. That leaves us with 4t squared. This is going to be plus 19t minus 5. And you do that because if you don't, that 2 is going to mess you up when you do your vertical factoring and your horizontal factoring, because it's going to appear in both of them, and your factors are going to have 2 times too big because the 2 appears twice. Now we just factor this piece using our old rules. What do 4 and negative 5 multiply to? We multiply to get negative 20, We want to add to get 19. So just start making a list, 1 and negative 20. That adds to negative 19. We switch our signs. Negative 1 and 20, that adds to 19. So we'll fill in our box. Our first term is 8t squared. Our last term is, our first term is 4t squared. Our last term is negative 5. And then our middle terms are negative 1t and 20t. We'll go across. Negative t and negative 5 have negative 1 in common. 4t squared and 20t have 4t in common. We will go up. 20t and 5, or negative 5, have 5 in common. 4t squared and negative t have t in common. So our factored form here, our height is 4t minus 1. Our width is t plus 5. All right, so let's try the next one. What do those have in common? 12, 28, and 24 are all multiples of the largest number they have in common is 4. I'm going to factor out the 4. So I'm left with 3x squared minus 7x minus 6. We're going to multiply. 3 and negative 6 is negative 18. How do we multiply to get negative 18 and add to get negative 7? Well, 1 and negative 18 is negative 17. 2 and negative 9 is negative 7. So those are my numbers I want. We'll fill her in. We got 3x squared, negative 6, and 2x minus 9x. Going across, 2x and negative 6 is 2. 3x squared and negative 9 is 3x. Going up, negative 6 and negative 9x is negative 3. 3x squared and 2x is x. So here our factored form is, and I made a mistake in the last one. I forgot my number I factored out. So on the last one, in front of your factors, you should have whatever we factored out, which was 2. So your answer should be 2 times whatever we had. In this case, it would be 4 times. Our height is 3x plus 2. And our width is x minus 3. So that's factoring. Remember your steps. You're going to want to multiply your first and your last and see how that multiplication can be used to add to get your middle term. Then you'll fill it in your box, factor across, factor up, and write it as length times width.